have audio. We do have audio. We're good. Okay, so I'm recording this. You can watch this later on. What I want to do is go over the exam from last semester to remind you of things, and we can do some of the math and the problems regarding the concepts. Now, reminder that the exam for you guys is on note sets. Oops. This is on note sets 9 to 17, I believe. Yeah, that's correct, 9 to 17. So anything within those note sets is fair game. I'm not going to ask you questions about bisection or Newton-Raphson. That's in the past. You use it for your project, but it is gone. Same thing with binary numbers. The main bulk of this is on matrices. That's chapter 4. Chapter 5 is on interpolation. And then the beginning part of chapter 6 is what we just talked about today, linear regression. That will be the exam. Okay? So, need to mute this. Okay, I was echoing. So, your exam will be very similar to this one. You'll have true and false questions, and then you'll have probably 3 longer problems, same like the last exam. Question 1, true or false? For interpolation, a 4th order polynomial may be used if we have 5 data points. I want you to think about this. If we have a 4th order polynomial, if we just write out what that means, that would mean that f of x is a4 x4, a3 x3, a2 x squared, a1x plus a0. So true or false? I hear true. Who says true? Who says false? It is true because we need 5 equations. 1 for a4, a3, a2, a1, and a0. 5 equations to find the 5 unknowns. Therefore, this is true. Because if I give you 5 data points, you can end up with 5 equations. How do you get them? Plug in the points, x and y, into this. That'll give you 5 equations and 5 unknowns. You can set up a 5, 5, 5 A matrix. In MATLAB, you do A / B, that type of thing. The system of equations below is represented by the provided matrix format. I want you to go ahead and tell me, well, that's the statement. The system of equations below is represented by the format. True or false? It tricked you. Don't rush. What's different about this compared to why you think it'd be false? The order of this column. Oh, this exam expected to be a little bit meaner. You guys did too well in the first exam. I gotta bring that confidence down, humble you. Obviously, I'm exaggerating. But not only did I switch the column order, because if you look at this top equation, there's a 4 here. I put them in a different order than what is presented. So what you should do is write out the matrix multiplication of this expression. So what's the first equation? Doreen, what's the first equation? The first equation. What's the first equation from matrix multiplication? Which equation does that look like? Up here. The second one. That's correct. Same deal. Lewis, what's the next equation? Is that there? That's the top equation. The last one is 2y plus 4x plus 3z is equal to 5. That is also there. That's true. You have to be careful. Don't just assume, oh, these numbers don't match those numbers. And it still represents the system, just in a different way than what you typically see. Tricky. That makes sense, though, now that you saw it. Gotta be careful. A square matrix can only have an inverse if its determinant is 0. What? Don't forget you have a formula sheet. If you want me to scroll up to the formula sheet, we can look, or scroll down. I posted your formula sheet, by the way. It's on Canvas. So here's the determinant of a 2x2 in general. If it's 3x3, 4x4, we don't know what this matrix looks like, but we always have something in the front with 1 over the determinant. This is the idea of singular versus being non-singular that we talked about in algebraic composition. If it's non-singular, you can decompose the matrix. What that means is you can't divide by 0. That's based on the determinant. So if the determinant is 0, do we have an inverse? No, it's undefined. We don't have an inverse. So if you come up back to that question, a square matrix can only have an inverse if its determinant is 0. That's false. It can't. You can fix this by saying non-zero, because you have to fix the expression, right? That's part of your requirement if you have a false statement. A square matrix can only have an inverse if its determinant is non-zero. It has to be some number. Does that make sense? Does that ring a bell? Does that ring a bell now? You're still kind of forgetting that term. Does that ring a bell? Yeah, like this expression. Because before you were like, what? You were freaking out.
No, because
Oh, I thought it was too easy.
yeah, I thought it was like.
Oh. She only gets one.
No, that's not.
Last semester, a good amount of people got it wrong. So, just note, again, knowing things conceptually and being careful. If we want to use cubic splines to connect 6 data points, we'll need at least 24 equations. I want you to take 2 minutes and think about this. This one was also split roughly 50-50 last semester. It was like 75-25. I'm just testing out the audio. Why isn't my transcript showing? Now we're recording. Okay. Yeah. In theory, it says it's recording. I'm going to double check later. If it's not, I'll do this on my own at home and post it. Yes, Jacob.
So for a cubic splines, it's 4n. Does that mean for fourth order splines it would be 5n?
Yes, that's correct. As it depends on the amount of unknowns you have in that singular spline. If you have a cubic spline, there's 4 unknowns. That's where that equation 4n, 3n, whatever comes from. Huh? I'm out? What? Oh, you're telling me true. That's what that T means. Yeah. This looks like timeout to me. Like, oh, slow down, Brett. No. True. How do you do false? Show me your best false. Using your head is the other one. All right, who says it's true? Hands who says it's true. Be proud. You can be proud. I see people like looking around. Who cares what other people think? You could be right. Who says it's true? Who says it's false? Okay. Somebody who says it's false, tell me why it's false. Dexter.
Oh. So you need n test one, oh wait, okay, so we have n test one data point, we have 6 data points. So n equals 5. That means we need 4 times the n equation. So we
Uh-huh.
need 20 equations. That may be wrong though.
Dexter says he needs 20 equations. People who said true, do you buy that? Rebensley. Oh, you do buy it. Okay. Yeah, that's what I'm asking you. Who said true before? Like, if you said true, do you buy that argument? Kevin, do you buy that argument? You buy it. You bought it. It's sold. Yeah, so let's remember. And that's correct. It's false. Let's draw a picture. If I have 6 data points, I like to draw pictures. I think it makes things clearer. How many splines do I need? 1, 2, 3, 4, and 5. 5 cubic splines. 4 unknowns per spline. You need 20 equations. You do not need 24. So this would be corrected by saying 20. That's false. Does that make sense? People who said true, do you buy that now? Okay, 3.
Wait, so there's 2 different, because I was thinking of like another thing, obviously it's wrong, on this one, it's like one where it's like. Wait, no,
So let's write out a cubic spline equation. Let's say I write f1 of x. That might be a1 x cubed plus b1 x squared plus c1 x plus d1. That's 4 unknowns for that one spline. This first one might be f1. There's 4 unknowns for it. Each of those individual splines, there's 5 of them, each have 4 unknowns. So therefore, you need 20 equations to find all of them. That was for interpolation, where you just have one continuous curve connecting them all, one function. This is 5 functions that just happen to be pieced together. That's the difference between interpolation and splines. Interpolation is one f of x. The splines, there's multiple baby f of x's. Remember, they're mini interpolants that go in between 2 consecutive points. That cleared up? Okay, Eric.
Is a line is a function with a bunch of splines. Is there apparently more or less of a piecewise function, or is it very different?
I would say it's kind of similar to that,
But
because only the spline, like f1, for example, let's say that this is f1. This is only valid in this region between those 2 data points. I can't use f1 to approximate something over here, because f1's not valid in that area. It's only valid between these 2 data points. So in general, it's kind of like a piecewise function. I think that's a fair thing to say. Note, if you're confused by splines, I posted a video about splines on Canvas. A student asked me to do that. You can ask me to make videos. I'll be happy to do it for you. Just tell me.
not exactly the same. I mean, it's not exactly the same,
What is?
piecewise and this.
Yeah, I mean, it's like similar, but not exactly the same. But it's the same. If you need that to justify it to yourself, that's okay. I think that's a fair justification. Yeah. That's fine. Is that okay? 3.
so if it's like, instead of cubic spline, that 1 cubic spline, it's that, that's when we can use the A to the number.
We wouldn't be able to do that. Why not? If I have 6 data points I want to connect,
Yeah.
that means that I won't be able to have a cubic spline that goes through all of them. Just because if I have 6 points, I'm going to need something like a 5th order function to connect them all. But John, you have the right idea, right? If I tell you to use a certain interpolant, that's like question 1. In this question, it says I have 5 data points and I want to use a 4th order polynomial to connect them. That is one function going through all the points. If I had 5 data points and said I'm going to connect them using splines, I would need 4 separate functions, which means I would need more equations. I would need 16 equations if it was cubic, 4 times 4, as opposed to this where I only need 5 equations. Again, this is 4th order, so that's not a great comparison. If it was cubic, you would need 4 equations total. for one interpolant. But as soon as I make them baby interpolants, little splines, then I need 4 for each individual spline. Does that make sense? Okay, cool. Doubts about anything that I just went over? Cool. Question 5. If we use quadratic spline to connect the points below, the last spline will be linear.
But it's true. It's a close call. Yeah, so 8 to 9 is I think it's 2.0 and that's one thing. So 8 to 9 is that one. Yeah, I've seen that. It's not the one. That's tricky because with the X and the Y, like.
Yeah.
I see you
Got me again.
You have to know your stuff. Have to take your time. Last exam, people left in 20 minutes. Like half the class left in 20 minutes. I'm like, okay, that was a really easy exam. I don't want you to rush through the true and false, especially. Okay, who says it's true? Who says it's false? Okay, some people didn't raise their hands. Is that an F? That's an F. So, when we make the linear assumption, it's either going to be the first or the last spline, right? It's one of the two. And it's based on the shortest x distance. What is the distance between these 2 points? 1.01. What's the distance between these 2 points? 1. So it's true. The one that has the smaller amount is the linear spline. Does that make sense? Kevin? You can pick either. That's fine. I'm not going to ask you that because that depends on who you. Maybe some people will say you should always pick the first one if they're the same. Some people might say the last one. To me, it doesn't really matter. It's a toss-up. But, the students, it'll be true. Oh, this statement, this is true. If you're saying they were equal, I wouldn't give you that question because it depends on who you ask. Somebody might say it's false because it should be the first or something. I think it's a toss-up. It could be either. I'm not going to ask you that because that's a really mean question that we haven't talked about. For Bensley. No, it has to be the X value. Oh, no, you can't do that either. Sure. I guess. I'm not going to ask you that, so don't worry about it. All right. Question 1. The matrix A was decomposed into its upper and lower triangular matrices provided below. What is the matrix A? This is, yeah, I mean, kind of, but just a different one. But now I give you L and U. I want you to tell me A. So what is this testing you on? Matrix multiplication. That is what this question is testing you on. Because I know that A, when it's decomposed, will be L times U. Notice I gave them out of order. I gave U first, and I gave L second. It's called LU decomposition for a reason, because L goes first. So you have to do matrix multiplication. Go ahead and spend 2 minutes to do this. Good practice. You might have to do this type of thing on your exam, Eric.
So we're doing the reverse.
I'm kind of doing the reverse. I've given you L and U. You have to multiply them together to tell me what A is.
Can you show the formula sheet? I want to see like. Okay, so yeah, it's all like
I've uploaded this too, so double check on Canvas, read through this, make sure there's anything I'm not missing. That one doesn't have regression, but the one on Canvas does have regression. Sorry, go ahead, do this. The zeros help, right? That does make it a little bit easier. What is the first element in this matrix? Anybody get the first element yet? 1. That's correct. It's 1. Why? If we're going to take, this is element 1, 1, right? This is A11. That means we're going to take the first row and multiply by the first column. A11. That would be 1 times 1 plus 0 times 0 plus 0 times 0. We get A11 is 1. Okay? You get that wrong? Okay, just make sure. Okay? The next one is A12. Again, that'll be the first row and the second column. What's that? That's just 2. Okay? Am I going too slow here? Just baby stuff? Yeah. The next one is 3 for the same type of reason. What's the next one? 0. What's the next one? 1. Next one? 4. Next one? Next one? 6. That's good. Last one is the only like real challenging one here. It's 15 minus 16 plus 1 is 0. That is our answer. because this was just testing you on matrix multiplication, that's all you were doing. This was graded because if you had like a number wrong, I took off a decent amount of points because the whole question is testing you on matrix multiplication. That's all it's testing you on. You got to get it right. Yes. Yeah, I mean anything with matrices will involve matrix multiplication.
They've been so similar to a point where I initially did one of the questions on the previous one of the quadratic interpolation questions wrong initially.
Mm.
It's like I was just doing the matrix, I passed out. It was there the A matrix or whatever with the elimination, but then I overlooked the C
Right.
matrix with what they're set equal to, you know, but
Yeah.
that's not in wrong.
Right.
I overlooked it, and I don't find that.
Right. So this is our answer for part A. If you come to part B, it says, is the matrix H below the inverse of the matrix we found here? Prove it. How do you think we do that? There's a few ways of doing it. There's an easy way and a hard way. What's the easy way? Which is what I was hoping people would do. A lot of people tried the hard way, which became a real pain in the ass. They wasted a lot of time. Yeah. Multiply by I? Multiply what by I? Multiply H by I. Well, if I multiply any matrix by I, it'll be itself. So it's not that. Multiply what by what?
H, if you multiply A by H, you should get the identity matrix.
That's what it is.
Yeah.
If you multiply A by its inverse, that will be equal to I. So A times A inverse, which is the same in this problem as A times H, if that equals I, then it's the inverse. So this is another matrix multiplication problem that's testing you a little extra more with multiplying A times H. I mean, if people use their answer from A here and did it correctly, I give them full credit for this, even if they got it wrong. I won't double hit you on things, especially a problem like this. I would like you to show like some work, I guess, but yeah, I understand. Like, if you don't show all the work, you get the right answer. That's fine. I'm not going to take all. It's just easier for me to like believe that like you did it. Like if you made an algebra error and you show me like, oh, this is what I did, I can take off less points than if you got it wrong and didn't show me any work. You know what I mean? Because if you just show me the answer, you just got it wrong. It looks like to me you just wrote down random shit. Like, okay, that takes off way more points than like, oh, one calculator error that you showed me. Okay, -2. You know what I mean? Yeah, Eric.
So it's just a matter of just clearly like showing you like how you got that answer, what direction like you went.
Yes. So if you multiply these out, you will get the identity matrix. I believe that these are inverses. But that's the identity matrix. If you look at the first row in the first column, you get -24 plus 0 plus 25. That's 1. Yes. No, it can be either way. If I do 4 times 1/4, that's the same as 1/4 times 4. This is the only case where matrix multiplication order doesn't matter. If you're multiplying a matrix by its inverse, it will always give you I. Because think about it like this, Jacob. Let's say I tell you this is A, and I tell you this is H. This is the inverse of that. The order shouldn't matter what I call it, right?
That only applies for like the inverse, because if it's not though, then
Matrix multiplication definitely matters every other situation. It just happens to be that if you switch the order for the inverse, that's okay. Yeah. So if you went through this, you would end up getting 0 for the rest. If you look at the next one, It's negative 48 plus 18 plus 30. You see that? Again, I'm looking at the second column versus the first row. So first row, second column, negative 48, negative 24 by 2, plus 18 times 1, plus 5 times 6, that gets you 0. And you can do that. And that will give you ultimately the identity matrix. And then you are done. Again, this whole first question is just testing that you can multiply matrices. Any doubts about this? Okay. Question 2. A system with equations with 3 unknowns is shown below. Find the unknowns x, y, and z using Gaussian elimination with partial pivoting. Assume that there's no limit on the number of sig figs. Basically, you can store numbers in your calculator. You don't need to worry about chopping or anything weird. Just do your thing. And assume that your X matrix is always in the form X, Y, Z. What does that prevent you from doing? Yeah, I can't pivot columns if I can't change the X, Y, Z. I want you to do this in one particular way. So go ahead, spend 5 or so minutes on this as practice. And you're going to use partial pivoting. No, this is Gaussian elimination. I would tell you if it was LU. Nolan. No, I don't think so. Also, keep in mind, this problem was 30 points on the exam. Yes.
Could I, let's say, can I pivot, let's say, 2 rows and leave 1 row where it is, or do I have to pivot all 3?
You have to pivot correctly, meaning you need what specifically to occur once you pivot? What needs to happen? The greatest number in that column has to be along the diagonal. That's what the pivot is telling you to do, Jacob.
So if it says with partial pivoting, because I know a lot of people from SMS.
Yes, I'm aware that like Connor, for example, was
Yeah. he's
really
very
heated about this
outspoken
problem.
If it just says with partial pivoting, should we just partial pivot whenever possible?
Yes, that's what that means. If I said with partial pivoting of just the first column, then maybe Connor would have a point. But it's something that's in the note set that we've done in class, and Connor was all mad about it. And it's like, Connor, stop whining about it, because I mean, Tess got it. Tess was giving Connor shit for it. And Tess was like, "Oh, Connor, what are you talking about? He talked about this in class," and Connor still thought it was unfair. I did 8 points per pivot because you have to pivot twice in this problem. You have to pivot twice. It's designed to be pivoted twice. You pivot in the first column, you do your Gaussian elimination, and then when you have to eliminate the last element, you have to pivot that column as well. I'm going to do it in a second. Yeah, pivot the rows. I mean, in the second column, you have to pivot the bottom 2 rows to get the biggest element in the diagonal. I'll do it in a second. Jacob.
Would you lose points if for the first matrix we wrote, we did the first and we had already accounted for it?
No, that's okay. Doreen. Yes, it depends. Let's go ahead and do this problem. Do we feel ready? So, our matrix we have to write, because I tell you to do X, Y, Z, is 2, 1, 1, 8, 0, 4. Everybody's okay with that 0. 0, 3, 1. This will be equal to 10, 5, 3. So if we want to do partial pivoting of to eliminate the 8 and the 0 in that column, what do I have to pivot? The 8 and the 2. I got to pivot the first 2 rows. So we pivot once, we get 8, 0, 4, 2, 1, 1, 0, 3, 1. X, Y, Z. That will be equal to, don't forget, we have to pivot this column as well. So the 5 goes on the top and the 10 is in the middle. Is that okay?
Wait.
Yes.
So we pivot because we need like, wait, because you want to have the highest number in the diagonal.
Yes.
So that's why. Oh, because 8. Yeah, because 8's lower than 2.
8 is a position lower than 2, so you have to pivot it to get the highest number in the diagonal. That's correct. So now I need to do my Gaussian elimination to eliminate the 2. So I'll have E1 mod and do that whole thing. So what do I need to multiply the top equation by? 2 over 8, which is a fourth. And don't forget, you have to multiply by the right side as well. This becomes 2, 0, 1, then 5 over 4, which is 1.25. 5 over 4 is 1.25. Yeah, for Bensley. yes, that would actually end up being okay. I would have recognized what you were doing, and I would have given you full credit probably. And also, Doreen, to answer your question, I probably would have given you full credit as well if you were clever enough to recognize you can solve for one variable immediately. All right.
So I wanted to ask about this because, like, so for the pivoting, right? Like, I remember when you're going over it in class, because technically this problem, like, you could get the answer without pivoting.
That's correct.
Okay, but just because you want us to. That's
Just because I explicitly told you to pivot, I want you to pivot.
Okay,
because some people were mad, like, well, I didn't pivot correctly, but I got the right answer. I said, that's besides the point. I told you I wanted you to pivot, and you didn't do it correctly. So you got points off.
But could you also ask the question too, where it's like solve this problem, and then it had like, but with this many significant digits, and then we would have to figure
Sure.
out if we need to pivot then, because that's what.
That's possible as well.
Okay.
So that's our E1 mod. So what we'll do is we'll subtract that from E2. So that will be 2, 1, 1, 10 minus 2, 0, 1, 1.25. So what do we get? 0, 1, 0, 8.75. Is that okay? Again, I'm writing really big. Oh, I even have extra page here. Great. So our top row will look the same, 8, 0, 4. Our middle row now is 0, 1, 0. And our bottom row is 0, 3, 1. Five, 8.75, and 3. So yes, if you're clever and you recognize you can find y right away, sure, you can do that. But if I had a non-zero coefficient here, I would not want you to do that. I want you to keep going. Now, in regards to this middle column, we're going to look at these two rows, because the top row we don't want to pivot ever, right? Because that would make this bottom 0 and 8. I don't want to pivot the top row ever after this point. I will pivot between the two bottom rows to get the biggest element along the diagonal. So in that situation, I need to pivot the 0, 3, 1 with the 0, 1, 0. Does that make sense? Kevin? Well, that's a great conceptual question, right? The reason that we pivot is for what reasons? Anybody remember? Yeah, to avoid dividing by 0 and to avoid dividing by really small numbers, which will give you a big number, correct? So that's the reason. We don't want to divide by 0. We don't want to divide by small numbers. And that will give us giant multipliers that we may not be able to store in our system. So that's why we pivot. So we will pivot this. You'll get 8, 0, 4, 0, 3, 1, 0, 1, 0. Multiplied by x, y, z. That will be equal to 5, 3, 8.75. So again, if you're clever, you can find out that y is 8.75 right away. But if we wanted to eliminate the 1, how would we do that? We'd have to modify which equation? E2. So E2 mod. That would be a third of that matrix or that row. That would be 0, 1, 1/3, 1. Okay. And then we'll do E3 minus E2 mod. E3 is 0, 1, 0, 8.75 minus 0, 1, 1/3, and 1. 0, 0, -1/3, 7.75. Doubts about this? Okay? Okay. So now at this point, you have 8, 0, 4, 0, 3, 1, 0, 0, -1/3. That would be equal to x, or multiplied by x, y, z, to give you your B matrix, 7.75, 5, and 3. Now you can do Gaussian elimination or back substitution. Sorry, on that. Back substitution. What do we get for z? So 7.75 times -3, -21 or 22.5 or something. That's 23.25. Thank you. We get y by writing 3y plus z is equal to 3. What do we get for y? 8.75, which we already knew from the previous matrix. And what do we get for x? 8x plus 4z is equal to 5. What do we get for x? What'd you say? That sounds correct from what I remember. So, how do you check your work? Go back to the original equations and plug it in. You shouldn't get this question wrong because you can always plug it back in. And if you messed up, okay, I got to double check my work. Now, if you run out of time, that's one thing. But in general, this should be a question that you get correct.
We only pivoted one time, but we still give us no credit.
No. No, I took off 8 points.
8.
8. I gave 8 per pivot is how I graded it last semester.
So I
Eric.
have to always change which equation to modify all the time.
If I tell you to pivot, you're going to have to switch them around, right? If I didn't tell you to pivot, you didn't have to.
So I can't pivot E1 twice ever.
No, because what you want to do is to make sure that you pivot to get the biggest number in that column and along the diagonal. Once you're done with eliminating that first column, that E1 should be fixed for the remainder of the time.
So whatever equation created set of numbers along the diagonal for each iteration.
Yes.
of the main.
Yes. Yeah, but you have to be careful because you don't want to pivot the first row. If you're trying to make this number the biggest, the 3, if you want to trying to make that the biggest, you don't want to pivot the first column or the first row, I mean, because the 8 ends up in the bottom left corner. You've undone your work. When you're looking at this diagonal, you're always going to look at equations below it and pick equations below it to pivot. Does that make sense? Okay, cool.
But then I see another short. But then it also needs to be a shortcut to get to where we have zeros in A31 and A32. Well, for this from particular.
Yeah.
Because in a lot of others, we'll have to do an additional round.
Correct. So,
I mean, you're not going to make us like, if I mean, like you said, you'll make us pivot twice, but then what about 3 times? They're not necessarily.
you won't need to if you have a 3x3 matrix. If I give you a 4x4 matrix, which I highly, highly doubt I would ever do to you guys, you wouldn't need, huh? I would never actually do that. Are you kidding? That was not sarcasm.
So it's like you
No,
cannot,
that was serious. I'm not going to do that to you.
so it's like you cannot pivot 3 by 3 times.
Right. That's only trying to eliminate 2 columns, right? Because you're only going to pivot a maximum of twice
Because
to
if
do
you
that.
eliminate all the columns, you just eliminate the entire.
Right. Okay. Last question. The table below shows 3 data points we would like to connect with linear splines, which is supposed to be easier than quadratic splines. But because we didn't see examples of that in class last semester, people freaked out. I wanted them to think, because it's the same type of thing. You just got to come up with the right equation. So I give you 3 points. Write equations in the matrix form AX equals B that may ultimately be solved to find the unknown coefficients of the linear spline. You don't need to solve it, but I want you to write those equations out. So take a second, try this with the linear spline for benzene. No, it does. Linear works out nicely. It's only with quadratic that it ends up being a mess, or cubic. Linear, you don't need to assume anything. You just got to make the equation. What's your next homework? I did? Okay. I couldn't remember. Yeah. No. Because I need you to show me what your unknowns are, right? Because you have unknowns, and if you just write it augmented, I don't know what those unknowns are, right? How are you feeling? Calm down. What? Natalie. Okay, medium. Actually, thumbs down. Okay. Who has thumbs up for me? Okay, some people have thumbs up, so that's good. Let's discuss this. If I have a linear spline, what is the equation of that spline? AX plus 1. Or AX plus A naught. Sorry, not AX plus 1. AX plus A naught. This would be A1X plus A naught. And maybe if you want to call it something else, we'll have different coefficients, B1X plus B0, whatever you want. But they each have a different slope and a different y-intercept, right? We need 4 equations. We have 4 unknowns. And we know that these 2 points are on the first spline. And we know that those 2 points are on the second spline. So what that means is if I say that f1 of x is a1x plus a naught, this will be, we can get 2 equations from this, right? We know that spline's valid for x equals 2 and x equals 3. So we'll do f1 of 2 is 2a1 plus a naught. f1 of 3 is 3a1 plus a naught. Does that make sense? Actually, have this look of skepticism.
No, it makes sense.
Okay. Remember, a1's the slope. I'm plugging in these x values. They have to satisfy the equation. So this is the first spline. We can do the second thing with the second spline. Again, this was, I wrote it as b1x plus b naught. Again, you can call it whatever you want. You can call it m1 and b1, like mx plus b if you want. It doesn't matter. This equation is true for which x values? 3 and 5. So I'll do f2 of 3. That is equal to 3b1 plus b0. And f2 of 5 is equal to 5b1 plus b0. Is that okay? Each of these equations, what's f1 of 2? 3. I gave it to you in the table. This is 3. What's f2 of 3? What's f2 of 5? 1. Do we buy that? Colby? Yeah, okay. So now I want you to write it as a matrix. So what size matrix do I need to write? 4 by 4. That's correct. And our X matrix can be those unknowns. Maybe I'll do A1, A0, B1, B0. And that will be equal to our coefficients or our answers on the right side of the equal sign. So what's our first row? Nolan. Yeah, 2, 1, 0, 0. What's our second row? It's 3, 1, 0, 0. Am I losing anyone here? How are we feeling about Natalie? Does this make sense? Okay, cool. Wyatt, give me a thumbs up the answer. Kind of. And if I look at this equation at the top, this is 2 times A1 plus 1 times A0. 2 times A1 plus 1 times A0. There are no B1s or B0s in that equation. That's why you put zeros there. What is the next equation? 0, 0, 3, 1. We switch. Because this equation is not based on A1 and A0. It's based on B1 and B0. The last one would be 0, 0, 5, 1. And now the right side would be 3, 6, 6, 1. And that's your answer. Does that make sense? Yes. No, it should be 4 by 4, right? We have 4 unknowns. Is this okay? Okay. Part B. The matrices A and B are defined in MATLAB. What single line of code should you use to get matrix X? 99% of people got this right. Eric.
A backslash B.
That's correct. X is equal to A backslash B. Everybody got that right. One person did something I've never seen before. I don't remember who it was because I don't think I even know who they are. I usually know my students. I did not know this person. Kind of makes sense. From the equations in the, what was their answer? I don't remember what their answer was. I'd have to look at my scanned exams.
It was sort of out of the ordinary.
It was out of the ordinary and wrong. So, 2 more questions. Yes. Yes, that will work. Some people did write that because I think Rodrigo might teach it like that. A times the inverse of B. Oh no, it's the inverse of A times B is how you would have to write it. I think 1 or 2 people did write that. I gave them credit for it. That's fine. Okay. From the equations in the form of AX equals B, find the determinant of matrix A. So how do I find the determinant? Eric.
Multiply all the terms that go from A11 to A44.
That's correct, but only after what? Doreen. That's correct. So what we have to do is eliminate this and this. Once you eliminate that, you can find the determinant. So you have to do 2 extra steps of Gaussian elimination for this problem in order to get those to be 0, and then you can find your determinant. That makes sense, Colby? You can pivot if you'd like. I didn't tell you to pivot. You don't have to. Because remember, if you pivot, that does impact the determinant. In what way? Yeah, depending on how many times you pivot, it might be negative of itself or itself. An odd number of pivots is a negative of the actual determinant. So if you wanted to pivot, you could. But all I really wanted you to do here was eliminate the 3 and the 5, and then you can just find the determinant by multiplying the matrices. And I don't care about this other stuff, really. That stuff doesn't matter. All I need to do is to eliminate the 3 and the 5. So we'll just do this quickly because we're running out of time. We'll modify E1. What's the multiplier? 3/2 times 2, 1, 0, 0. That will be 3, 1.5, 0, 0. We'll do E2 minus E1 mod. E2 is 3, 1, 0, 0 minus 3, 1.5, 0, 0. That's negative 0.5 with a bunch of zeros. I know I went through that quickly, but does it make sense? That okay? Okay. And now I want to eliminate the 5. So what will I modify? Which equation, Eric? Because I'm just asking for the determinant of A. We don't care about the B matrix. I just want to know the determinant of that first 4 by 4. Nothing else matters because we're not solving a system. That's the only reason the B matrix matters is to solve the system. But I'm just asking for the determinant of A. So what equation do I need to modify to eliminate the 5? Nolan. E3, that's correct. Because that's the diagonal term is this term where the 3 is. So we'll do E3 mod. That will be 5 thirds times 0, 0, 3, 1. That'll be 0, 0, 5, whatever 5 thirds is. Then we'll do E4 minus that, which will be 0, 0, 5, 1, subtract 0, 0, 5, 5 thirds. We have a 0, 0, 0, 1 minus 5 thirds is negative 2 thirds. That would be the final row in our matrix. Is that okay? Now that we've eliminated everything and gotten everything in the proper form, now we can multiply the diagonal. So the determinant will be the product of the diagonals. So the determinant of A could be 2 times negative a half times 3 times 2 thirds. That gives us negative 2, I think. Oh, sorry. That gives us positive 2. Positive 2 was our answer. How was that? So this exam last semester, just one more part that we'll do. But in general, this exam was a lot easier than their first exam. They felt that this was kind of a gift. I think the average is like an 86 or something. I mean, some people messed up the splines and stuff, but the average is still pretty high. Questions about this part? We have one more part. Okay, last part. After solving the matrix equation from earlier, the slopes of each linear polynomial were found to be 3 and negative 2.5. If a robot were to travel along the splines, what's the length of the path it follows? So, there is an annoying way to do this problem and a very easy way to do this problem. What do you think the annoying way is? Let's integrate. Let's go to the formula sheet. You can use this equation to find the curve length. You have to take the derivative and then do that thing. And the derivative's not hard. It's a line. It's just a constant. So that's one way of doing it. What's the other way of doing it that ends up being a little bit easier? Huh? Trig. What about trig? Pythagorean theorem. Remember, this is where that's derived from. With a linear splines, let's go ahead and draw this. If I do 2, 3, 3, 6, and 5, 1, and that's your first thing, we want to find that distance. We can draw a right triangle if we want. What's the distance in x? What's that distance? That's 1. What's the distance in y? 3. So what's the blue? That's going to be the square root of 1 squared plus 3 squared. That's the square root of 10. If you want to go the other way, same deal, except now you have to look at different x and y values. What's the change in x? 2. What's the change in y? 5. So the length will be the square root of 2 squared plus 5 squared, which is the square root of 29. The total length will be the sum of those two, whatever that is in your calculator. I think that's an easier way of doing it. If you don't like that way, you can use the equation. Because in the problem, I tell you the slopes. The slope of the first line, this is m is equal to 3. And this m is negative 2.5. I tell you that in the equation. So that means the blue spline, F1, is 3x plus, a naught F2 of x is negative 2.5x plus b naught. Do I need to know what a naught or b naught are to solve this? No. Because if you look at the interpolation equation, the curve length equation, L is equal to the integral from a to b, the square root of 1 plus the derivative squared. That makes sense? So, what is, let's say, L1? That would be the integral from what to what for L1? From 2 to 3. That's where the first spline exists. This is the integral from 2 to 3. The square root of 1 plus, we said that f1 of x is 3x plus a naught. What's its derivative? 3. Oh, look, that's the same thing we have up here. So this would be the square root of 10 integrated. What's the integral of that? Thank you. I know that's a dumb question to ask, but got to make sure. We'll integrate that and we get the square root of 10 as our length. Easy. L2 is the same deal, except this time our f2 prime, or our df2 dx, ends up being just a slope that's negative 2.5. So we integrate that from 3 to 5. 3 to 5. Square root of 1 plus negative 2.5 squared dx. That's what, 5 over 2 squared, so that's 10 over 4. Is that right? Did I do that right? That doesn't seem right. 25 over 4, not 10 over 4, 25 over 4. Dx, which is the same thing. Again, you have your calculator. I just don't have one with me, so I'm doing it grossly. Square root of 29 over 4. If you integrate that, you'll end up getting whatever the answer was from before. And then you can go ahead and add that to square root of 10. So you can do it either way. You can do it with the formula if you want to do the calculus. If you are clever and want to do the Pythagorean theorem, I think that's easier. You can do that. You'll get the same result. Any questions about anything I did today? Question or just stretching?
No. Large and decomposed.
I don't know yet. I haven't written it. I think it's going to be maybe a little bit harder. Both? No, we'll see. No, they're extra credit. I'll post this exam. A lot of people got the Maclaurin series wrong last semester. I gave them a new one just to mess with them. And on the final, I gave them a derivative to do because they did not know how to do derivatives. It infuriated me, so I kept asking them that question. You guys were okay. I'm not going to ask you questions like this on this exam. But I did prep them for regression. I said, find the local minimum, take the derivative of this with respect to x, that equal to 0. Is it a max or a min? Prove it. How do you prove it? Second derivative. You take the second derivative of it and see if that's positive or negative. And that's how you do that. Okay. If you have questions, let me know. Thank you. I'm going to upload them.